Hello students, how are you?
Now the electric flux, while reading electric flux, we have to clarify that many electric things we have studied till now, right? What things we have studied? Electric field, electric field strength, electric field intensity, all those things we studied, right? Now electric field, theoretically what is called electric field is a little different than electric field intensity numerically, right? But numerical speaking, by doing more and more numericals, you will observe that whenever we are saying electric field intensity, we mean the same thing by saying electric field or electric field strength or electric field intensity, because in numericals you will see that many a times it will be asked calculate the electric field, calculate the electric field strength, calculate the electric field intensity. Whatever we say, it is the same thing, electric field intensity, and the symbol of that was E. Electric field intensity is a scalar quantity or vector quantity? It is a vector quantity, right? That's why E arrowhead I have mentioned. Now till this it was clear, but in this particular session we are going to learn what is electric flux. We are going to be introduced with a little new concept, electric flux, what it is. Now see, to make you familiar with this, let me take this example. Imagine one huge tube which water is flowing through the tube. Okay, it's a very huge tube, a very small cross section only I am showing you for a clear understanding. Okay, from where water is coming, from where water is going, it's a huge tube that it is continuing. Just this much I am showing. Now we can imagine that this is not true. We are just imagining this flow of water is consisting of a huge, many, very large, nearly infinite number of narrow tubes, right? Very small, narrow tubes, and all the tubes are carrying water in that. Okay, so that the entire flow is having this entire flow of water, right? That entire flow of water can be considered as infinitely large number of narrow tubes of water we can consider, right? Now let us say all these tubes which are taking water through that are called one line. So if all the lines are together, the water is flowing. Is it clear? And in electric flux concept, what we'll say is we are talking electrically now. Whenever there is a positive side means there is a charge, positive charge, and there is some negative charge. Positive to negative electric field lines are going. This we know already, right? Electric field are going. This we know already. Now, all these electric field lines you can compare with that all the tubes, narrow tubes containing flow of water, and in together all the little flows together become a huge flow. Like that, all the field lines together is the electric field altogether. And the intensity, how to measure that? 1 by 4 pi epsilon naught q by r square, all these things we have studied already. Now you can think that each electric field line is one narrow tube of water, and in together whatever is going, that is a electric field. But now I know the question still remains, what is electric flux then? Okay, then the number of electric field lines per a specific area, for a certain area, and to measure it specifically, we are taking a unit cross-sectional area which is perpendicular to the electric field line. See, electric field lines are in this direction, so perpendicular to the field line, if I am taking a unit cross-sectional area, how many electric field lines are hitting that? That is called electric flux. To be more accurate, I must say that it is the relative number of electric field lines, because your question will be, if there are infinite number of lines, even if we take in a small unit area of cross section, how will we know how many lines exactly are passing? It's the relative number. If more number is passing, more the electric flux is more. If less numbers are passing through that, electric flux is less. Okay, and the symbol of electric flux is phi. The symbol of electric flux is taken as a phi. Now you have understood the concept, right? How it is measured. So there are electric field lines. Now if I am taking a particular, let me show you some plate. Let us say if I am taking some plate. Now see, these lines are passing in 3D. You imagine these lines are passing like this. Now if I'll keep it, if the plane of this area, if I plane of this is perpendicular to this, then more lines will be hitting it, yes or no? But if I'll keep it at some angle, less number of lines will hit it, yes or no? Did you get it? See, for example, I am keeping it perpendicular. Now you see 4 lines are hitting, right? Now if I keep it here like this, 2 lines only are hitting, because one line is going above, other line is going below, it became 2 only. Like that, if I make it completely flat like this, no line is passing, right? So how much flux? Flux is the number of electric field lines hitting the surface of a unit area. Let us say this is the surface of a unit area of cross section. Now how much it is? Do you understand that when it is perpendicular, then only maximum lines are passing? When the angles it is slanting, less number lines are passing. And when it becomes perfectly parallel, when the plane of the sheet, plane of the surface is perfectly parallel to the electric field, then no line is passing. Okay. Now to define, we are going to, you have understood it theoretically, we are going to define it mathematically. And to define it mathematically, we have to define a term area. You can think this as a rough part. So area we are talking. Now area is a scalar quantity or vector quantity. Till now what you have understood, always we have taken area as a scalar quantity. And of course if it is a number, area is 4 meter per second, 4 meters square or 5 meters square or 6 meters square, some number it is. So it will be a scalar quantity only, it's not having any particular direction, generally speaking. But here we will be treating area to be a vector. And why? And the area, we will be associating the area with a direction. And what is the advantage of that? In some time you will see. Now what is the direction of the area? Now I'm sorry, the direction of the area is perpendicular to the area. For example, this is one surface. What is the direction of this surface? If it is asked, the direction is perpendicular to the surface. Okay, let us say this is the tip of the pen, right side is the tip. So this is the direction. If I say that the direction is always perpendicular to a surface, then also the question remains, because this side also is a perpendicular. So perpendicular, when we say, also 2 possibilities are there. It can be this side also, it can be this side also. So which is the direction of the area? 2 directions cannot be possible. Which is the area? Then the direction of area is always considered to be outward normal. Outward normal. What do you mean by that? Let us say this is a surface. It is in a 2D I am showing it a ring like, but you imagine this is a sphere. Okay. Now at the center of the sphere there is a plus q charge. Let us say. Now from plus q in 3D, all the directions, infinite directions, electric field lines will be coming out, yes or no? In all the direction, infinite numbers will be coming out. Now if I will be taking a particular area here on the surface, I am considering one particular area. Through that area, what is electric line is coming out, right? Now this is the outward direction, yes or no? And this side into the board here is the inward direction of that particular area. Area symbol is S, and now we will be giving a vector symbol for that S, and a small area if you are taking, we will be considering that as a ds. Okay. Now if it is a vector, which is the direction of that vector? It's a outward and a normal. Means normal means the direction must be perpendicular to it, and even if it is a perpendicular, it can be this side or this side, then I am defining it always it is outward. So from outside normal, outward normal is the direction of the area all the time. Is it clear? Now if I want to make it a little more clear mathematically, how will say? Now see, you are having the concept of a unit vector, right? Unit vector Now, along, this is the direction of the area, let us say. Then what is the direction of a S? This is nothing but it's a magnitude multiplied by the unit vector along S. We can write this way also, right? You are familiar with this concept from last year. In a vector we had studied this. Remember? We can write S vector like this also, or a ds vector is equal to ds is this magnitude multiplied by n cap. We can show it here like this. Fine. Now whatever is in the red, these were actually area vector, defining the area vector. I had said these things. Now whatever we are going to talk, area vector will be something which will be used in this concept. That's why I gave some introduction part. I am erasing this area vector part. Well, now coming to the same concept again, there are three possibilities. Broad I am showing. This is like this. This is like this. Lines are going which are hitting it normally. This is one position. Let us say this is a case 1. Now I can put it like this also. Totally the plane of the area is along the electric field. Like this also I can put, and this is, let us say, case 2. And a third case we can take, consider that it is neither, see, first thing was it was perpendicular to the electric field lines, second case it was parallel to the electric field lines, and the third case it is at any other angle. It's making some angle with the field line. Now see, what angle it's making? If the area is perpendicular, the plane of the area is perpendicular, but what is the angle between S and E? Listen carefully. If it is perpendicular, then area is along this direction, right? So S is along this direction and E also is along this direction. So what is the angle between S and E, or E and S? If theta is equal to angle between E and S, then here theta is equal to how much? 0 degree. Don't you think? If here the plane is perpendicular, so the angle between the plane of the surface and E is 90 degree. But what is the angle between the surface? The area we have considered as one vector, and its direction, area's direction is this. Along with this direction, E is making 0 degree only. So what is here? You tell me. See, the plane is like this. The direction of it is this way, and E is along this direction. So what is the angle? Theta is equal to 90 degree. And here the outward normal is this. This is the direction of the area, and E is of course in this direction. So this is the theta. So theta is equal to theta here. So these are the three cases. Clear? Now, mathematically speaking, what we have understood, that I am going to explain mathematically now. What is electric flux in all the three cases we see? By discussing all the three cases, we are discussing all the cases, because either the surface, either it can be perpendicular to E so that its direction is parallel with E, or the surface can be parallel to E so that the direction is perpendicular to E, or the surface can be having at any angle so that there will be some angle between the plane and E. That is, let us say, theta. Okay. Now, what is electric flux? We have understood what is electric flux theoretically, but mathematically, electric flux phi is equal to E dot S. Okay, it's the dot product of the electric field intensity and the area which comes in contact with the field. Okay, so area, when we say, you remember S multiplied by the not multiplied, S associated with its direction. So what we can know, A dot B is A B cos theta, we know. So E dot S is equal to ES cos theta. Phi is what? Electric flux, right? Therefore, in the first case, electric flux is equal to how much? You can dictate. Oh, okay, you may not respond in a video lecture, but You think simultaneously along with me. What is electric flux for first case? Es cos theta, right? Es, whatever is the direction or whatever the magnitude, into cos theta. What is theta here? Cos 0 degree. Cos 0 is equal to 1. So this is equal to simply Es. Yes or no? And here, in second case, phi is equal to Es cos of 90 degree, and cos 90 is equal to 0. So phi is equal to 0. And here phi is equal to Es cos theta. Whatever is the theta, it depends on what is the angle. Now listen, here you should be careful about one thing. That is, in some question it may be given, the angle between the plane of the surface and E is 90 degree. If it's given, listen carefully. The angle between plane of the surface and E is 90 degree. This is the first case. And this also can be said as the direction between electric field and area is 0 degree. The same thing means this only, case 1 only. The direction between area means area direction is outward normal only. Direction of the area, the angle between the area and electric field is 0 degree. If I say case 1 only is meant, or angle between plane of the surface and area is 90 degree, then also case 1 only is meant. Remember, in numericals it will be given like that. We have to read the lines very carefully, which angle it is giving. Now, what is this? You tell me. Okay, again, I am only telling you. See, if the surface is lying like this, the plane of the surface is along E. Plane of the surface is along E means the angle between E and the area is 90 degree. Okay. And when this happens, angle between E and S and E is 90 degree, then electric flux is equal to 0, right? Because of this, and this is any one of the angle. Now here also you have to remember very nicely, because in the numerical, if it is given the angle between area and electric field, if it is saying the angle between electric field intensity and the area is 30 degree, then this theta is 30 degree. But if it is saying that the angle between the plane of the area and electric field is 30 degree, then this angle will be 90 minus 30, that is 60 degree. Got or not? See, there is a little confusion here. If you didn't get, you stop it or take the video a little back, listen what I said again and again till you understand. We will be doing some numerical also, so that it will be clarified this point. Now, the question is in front of you. You can pause the video, note down the question, read it carefully, then only you continue with the video so that you can understand what we are talking. The question is, define the term electric flux, write its SI unit. Now define the first part of the question I read. Define electric flux. This is from my note, you can find out. This is a theoretical question. But what is the SI unit of electric flux, you tell me? We said E is equal to, flux phi is equal to E dot ds or E s cos theta. Anyway, cos theta is just a number. E s, what is the unit of E? Isn't it Newton per Coulomb? E is equal to F by Q, you remember? So Newton per Coulomb. So Newton per Coulomb multiplied by S. S is area. So meter square. So Newton meter square per Coulomb is the SI unit of electrical flux. Question second part I am taking. E is equal to 3 into 10 to the power 3 I cap Newton per Coulomb. 3 into 10 to the power 3 I cap Newton per Coulomb. What is the electric flux due to electric field? E is equal to 3 into 10 to the power 3 I cap Newton per Coulomb through a square of a side 10 cm when it is held normal to E. Square of side 10 cm. See, square of side 10 cm, 1 square is 200 or 10 to the 4, I am sorry, 100 cm square. That's 1 meter. So this is 10 to the minus 2 meter square. So area is equal to 10 to the minus 2 meter square. Now also it is said that through a square of side this much which is held normal to E. S is held normal to E. That means angle between E and S is equal to 90 degree held, which is held normal to E. So the second numerically you can see, and I hope you have noted that already, which says given a uniform electric field E is equal to 5 into 10 q I cap Newton per Coulomb. What is given? It is the next question, right? E is equal to 5 into 10 q I cap Newton per Coulomb. E is equal to 5 into 10 q I cap Newton per Coulomb. I cap means what? It is along x axis. So if we are taking it like this, if it is our x, this direction is our y, this direction is our z, then E is along this direction. This is E. And the magnitude of that E is 5 into 10 to the power 3 Newton per Coulomb. Find the flux of the field through a square of 10 cm on a side whose plane is parallel to YZ plane. Now see, whose plane is parallel to YZ plane. Listen carefully. The plane of the square is taken whose plane is parallel to YZ plane. So this plane is this parallel to YZ. The plane is somewhat like this. It is parallel to YZ plane. That means it is giving perpendicular to E, electric field, right? So in the question you have to read carefully. This is what I was saying. It could have given the square is perpendicular to E. If it is given, it's the meaning same. If the square is lying in a YZ plane, it's giving it's the same. Or also it can be given the area, the plane, the square's direction is along electric field direction. It could be given in that way also. In all these three cases, we will mean the same. This is the explanation what it is given. Okay. So what's the question? Given a uniform electric field E is equal to 5 into 10 to the power 3 I cap Newton per Coulomb. Find the flux of this field through a square of 10 cm. So the side of the square is given to be 10 cm. So this is equal to again how much? 10 to the power minus 1 meter. This is the side whose plane is parallel to YZ plane. Fine. So find the flux. So now you say what is the flux? Phi is equal to E dot ds, right? So E ds cos theta. What is the theta? What is the theta? Angle between ds and E. Don't you think both are in the same direction, that is theta is equal to 0? So this is equal to cos 0 is equal to 1 E ds, right? So E is given in the question 5 into 10 cube multiplied by S is how much, right? How much? Square of the side, right? 10 to the minus 1 into 10 to the minus 1. 10 to the minus 2 meter square. So put it 10 to the minus 2. E ds. See, instead of ds is a very small area, right? So everywhere we will be taking S only. E dot S. So E dot E S cos theta and E S. Okay. E ds when we are taking, when a very small part of that area also if filled, right, we will use the notation ds. So here it is not required. Is it clear? So 5 into 10 to the 3, that's E into S. So this is equal to how much? 50, right? And what's the unit? Phi unit? Yes, Newton meter square per Coulomb. Clear to everybody? See, if you miss this unit, half mark will be lost according to your CBSE rules. Newton's the units must not be missed. Okay. The next part of the question is there, which we'll take up here only. Next part asks, what would be the flux through the same square if the plane makes a 30-degree angle with the x-axis? Listen carefully. So I'm doing it again here. A bigger one so that you will understand nicely. Let us say this is x, this is y, and this direction is z. Now in the first chapter, first case, this plane, the square was along yz plane. So this was the square, right? It was in the first case. It was in the first case. But now it says what would be the flux through the same square if the plane makes a 30-degree angle with the x-axis. See, listen carefully. The plane means this plane. This plane makes 30-degree with the x-axis. That means its direction makes with the x-axis. What angle it makes? Isn't it 60-degree? See, instead of that plane, now you listen here. This plane is there. In this case, it was like this. It was perpendicular to x-axis. Now, if the plane will make 30-degree, this is the plane. Let us say, if the plane is making 30-degree, this angle is 30-degree. Is it visible to everybody? If the plane is making 30-degree, then what the area will make? The direction of this area is perpendicular to this, so it will be along this line, right? Now, this plane is making 30-degree, means how much this angle will be? Isn't it 60-degree? The plane is making 30-degree. The plane is making 30-degree. Then the perpendicular to the plane is the direction of the area, right? If this is 30-degree, this will be 60-degree, isn't it? Why? Because this plus this total is equal to 90-degree. So if this is 30-degree, this must be 60-degree. You understood or not? If the area is making 30-degree with the x-axis, then the direction of the plane is making 60-degree with the x-axis. So the direction of what? This is the s vector here. And now E is along this direction, along x-axis, right? Now the angle between E and S only is the theta in the formula ES cos theta S, no? So theta in this case is equal to how much? 60-degree. Is it clear? If this understanding is clear, it becomes very simple. And after that, again we will repeat the same process. Phi is equal to E dot S. E dot S. Now E is the same number only, 5 into 10 cube, right? And ES cos theta, E dot S, ES cos theta, but theta is now 60-degree. So cos 60-degree is equal to, then this is how much? 50 multiplied by cos 60 is equal to half. So this is equal to 25, and the unit is Newton meter square per Coulomb. Is it clear to everybody? Gauss law of electrostatics says that the total flux over a closed surface, is equal to 1 by epsilon naught times the charge enclosed by the closed surface, considering that the charge is taken in a vacuum. So what it means is, suppose we are having a closed surface. And what is a closed surface? The name itself suggests, right? You understand, a closed surface. You imagine one closed surface. Now in a closed surface, that doesn't mean that there is actually a surface, but this is one imaginary surface. Let us say at the center Q charge is there. Let us say plus Q charge is there. Now the total, surface integral of, as per Gauss law of electrostatics, total electric flux over a closed surface S. Let us say this total surface area is equal to S. Then total electric flux over a closed surface S in vacuum is 1 by epsilon naught times, total flux is equal to 1 by epsilon naught times the charge enclosed in the surface. This is the mathematical expression of Gauss law. Clear? Which says that what is phi? It is over the closed surface, the total flux. Let me write it total flux. And mathematically, to be more accurate, we will be saying flux over S, that is said, is equal to, over S means over the closed surface S, is equal to Q by epsilon naught. 1 by epsilon naught times Q. Why epsilon naught? In a vacuum, we are considering this in a vacuum. Otherwise, the permittivity of whatever is the medium, that 1 by the permittivity times the charge enclosed in the surface. It's very clear, right? Now we are going to prove the Gauss theorem for a symmetrically closed surface. Now one thing is this is true for any closed surface. That closed surface may be a cube. Inside that, if a plus q charge is there, let us say, then also total electric flux over the closed surface, which is a cube here, it will be that much only. Instead of taking a cube, let us think that is in form of some irregular shape, but it is a closed, then phi is equal to q by epsilon naught. It will be true for every surface. But as per the syllabus, we are going to prove it only for a spherical surface. Only it is for a mathematical ease, and since that is in the syllabus, we are taking up that. But with a little difficulty, it can be, with a little depth, it can be proved for any irregular surface also. Only the condition is that the surface must be closed, so that we can put this formula. Okay, now let us consider a sphere which includes a charge at its center equal to plus q. Let us consider that we are having a unit positive charge on the surface of the sphere, and around that a small area element, let us consider, that is equal to ds. What is the direction of the area? It is the outward normal, right? So let us say this is the direction of the area, and electric field, it is going out from the plus, it will go away, so electric field also in the same direction. And let us also say that the length of this distance between this plus 1 charge and the q is r, let us say. Now the electric field intensity at point, let us give some name to this point. Let us say this point is P. So electric field intensity at point P is equal to, or P is given by, what's the symbol we are taking, E. E is equal to, what's the electric field? 1 by 4 pi epsilon naught q. Actually that force q1, q2, and this charge, to calculate the field, we are taking a unit positive charge, so q into 1 became q only, q by r square. But to be more accurate, this is a vector quantity, right? So E is equal to, this side also vector, we can write r cap, and r cap is the unit vector along the opposition vector of r, where this, you know, it's a rough, where r cap is equal to r magnitude multiplied by n cap. Okay, so this is the E. R cap, we took the both side, left hand side and right side, became both vectors now. So E is equal to this much, fine. What is the little flux about the small area ds, or area element ds, is equal to, don't you think that E dot ds, phi is equal to E dot s, where s is the total area, E dot ds. So this is equal to E s cos theta, and theta is equal to 0 here. The E, r is in that direction only, s is in that direction only, cos 0 is equal to 1, right? So this is equal to Es, and what is E? 1 by 4 pi epsilon naught. Remember, these are magnitudes only. Now we will take q by r square Es cos theta. S is equal to how much? ds here. D phi is E dot ds. See, E ds cos theta. So ds. Fine. So d phi is equal to 1 by 4 pi epsilon naught q by r square into ds. From here I am writing, implies that total electric flux about the closed surface is equal to what? The closed integration of, this is the mathematical symbol, closed integration about the complete surface is equal to this much d phi, right? So this much is equal to the closed surface integral of d phi, you write it, 1 by 4 pi epsilon naught q by r square ds. Now to write it frequently, you have understood this, right? I am just erasing a little part of that so that I can continue from here. Now see, from here I am writing, so therefore phi is equal to closed surface integral of this much. Now since this is an integration, the constant part we can take out 1 by 4 pi epsilon q by r square. All are constants. R also is a constant because we are imagining that in between we are not changing. So let me take all the constants outside in this step only. So 1 by 4 pi epsilon naught q by r square I took out, and what remained inside that closed integral about the surface? Only ds remained. Now ds of this ds you will completely integrate. Don't you think that the area of the entire sphere is 4 pi r square? So this is equal to 1 by 4 pi epsilon naught q by r square multiplied by this surface integral of this closed surface integral of a ds is nothing but 4 pi r square. Yes or no? Now 4 pi got cancelled, r square got cancelled. So this is equal to q by epsilon naught. And what is q? It is the charge enclosed in the surface. So we came to the conclusion, therefore phi is equal to q by epsilon naught. So this here we have proved the Gauss law. This one is the Gauss law, right? Gauss law says that the total electric flux over a closed surface is equal to 1 by epsilon naught times the charge enclosed in the surface. So this is what the Gauss law says, right? That we have proved mathematically from the concept of how we have proved. This is the proof of Gauss law. For a symmetrically closed surface, for a sphere we have proved, but which is not there in your syllabus, but I must mention here that it is not only for sphere. If any closed surface we take, this is always true only. Phi is equal to 1 by epsilon naught times the charge enclosed in the surface. And if in a closed surface there will be, let us say, q1, q2, q3, there are many charges are included, then what will happen? Phi is equal to 1 by epsilon naught times the charge enclosed in the surface. So instead of a q, in place of q, you have to write q1 plus q2 plus q3. So all the charge enclosed in the surface will be this charge. Fine? Clear to everybody? So finally, if we write mathematically, this entire thing can be expressed as phi is equal to surface integral, closed surface integral of E dot ds is equal to q by epsilon naught. This is nothing but the Gauss law of electrostatics in mathematical form. Clear to everybody? Now we'll see the deduction of Coulomb's law from Gauss theorem. The Coulomb's law we are familiar with already. That Coulomb's law we will derive from Gauss theorem. Okay. Now see, again we will be taking a sphere. Whenever a closed surface is to be imagined, for the sake of easiness in proceeding mathematically, we are taking a symmetrical closed surface, and the most symmetrical closed surface is a sphere. That's why we are taking a sphere only. Now imagine that at the center of the sphere, let us say that the point is O, and there is a charge plus q, and along the plus q from here plus the electric field lines will be going in different directions. Let us say again on the same thing, at the P point we are taking, and this area is a small area element at ds we have considered, and the direction of that area also is equal to, or let us say this length is a r, OP is equal to r we have discussed, and this is n cap and this is E. So we are taking the same example again. Now imagine that there is a unit positive charge placed at a point P. Fine. Now according to Gauss law, what Gauss law says? The total flux is equal to closed integral of E dot ds is equal to 1 by epsilon naught times q, the charge enclosed in the surface. Yes or no? This is according to Gauss law. Now we don't know Coulomb's law, and we will see that from Gauss law, if we will start, how we are coming to Coulomb's law, or how Gauss law and Coulomb's law are in agreement with each other. That we are going to see. Okay. Now, from this, what we can conclude, E dot ds, I'm sorry, this is a vector, right? E dot ds, so closed integral of E ds cos theta is equal to q by epsilon naught. Yes or no? Now, what is theta? Theta is the angle between E vector and ds vector. That's the angle between the electric field vector and area vector. And since both are in the same direction, the cos theta is equal to 0, so cos 0 is equal to 1, implies that closed integral of E ds is equal to q by epsilon naught. Cos theta became 1 because theta is equal to 0 degree, right? Implies that E ds, E closed integral of ds is equal to q by epsilon naught. Yes or no? Implies that what is ds? ds if it's integrated, ds if it's a closed integrated, this is the total area which is equal to 4 pi r square. Implies that E multiplied by this much is equal to 4 pi r square is equal to q by epsilon naught. And from here I am writing, or why to write q by epsilon naught, implies that pi epsilon 0 q by r square. Yes or no? See, this 4 pi goes, 4 pi epsilon naught I wrote inside, this r square came, so q by r square. So E is equal to 1 by 4 pi epsilon naught q by r square. This is electric field according to Coulomb's law only, right? Now, instead of this plus 1, imagine that there is some other charge which is equal to q. Okay, let us say that instead of plus 1, you imagine q0 instead of plus 1. Then what will happen? Here plus 1 electric field, force is equal to, implies that force is equal to E multiplied by q, and since that q was 1, then it was E only. But if q is q0 now, so E into q0 will be the force. Therefore F is equal to, write it, 1 by 4 pi epsilon naught q by r square. This was E multiplied by q0. Okay, so force is equal to 1 by 4 pi epsilon naught and product of the charges separated by the square of the distance between them. This was what? Coulomb's law. We started with the Gauss theorem and we reached at Coulomb's law. Fine. So Coulomb's law and Gauss theorem are in agreement with each other, and this is the deduction of a Coulomb's law from Gauss theorem. Now, I would like to give you one perspective. See here, till now by Coulomb's law, whatever we have studied, we mostly studied it mathematically, right? You see, Gauss saw it in such a way that the number of field lines passing per unit area of a cross section is a flux. So he thought in a different angle, flux. He didn't introduce it, but he thought it in terms of a flux, and what he realized, Coulomb merely measured it in Coulomb's brain. Let us say what Coulomb said, in that the flux idea is not there, but F is equal to this much only, and from Gauss idea also if we come, we are finding F is equal to this much only. So what I want to say is these are two different approaches, but both lead to the same conclusion. Hope this is clear to everybody, but to make it further clearer, we will be taking up one numerical. Hope you have noted down the numerical already, which says define electric flux. Is it a scalar or vector quantity? Electric flux is a scalar quantity, right? Flux is equal to E dot ds, dot product of two vectors is a scalar, as simple as that. And the second part is a point charge q is at a distance of d by 2 directly above the center of a square of a side d. There is a square of side d, and from the center of the q at a distance d by 2, let us say this much, there is a charge q. Charge q is placed at the center. Now see, it's a square, but Gauss law is always talking of a closed surface. Is the square a closed surface? You imagine a cube with the side d. One cube. What surface is given on this? So on that you build a cube. So if the cube is the closed surface, you imagine this surface is called Gaussian surface in fact, and Gaussian surface are not really existing made with some material. It is not made with some material, but it is in your imagination. When you build one cube over it, then above the surface at a distance of a d by 2 it is given, right? Yes, at a distance of a d by 2 above the surface, this is the base of the cube, this side is the base of the cube. So above the base at a d by 2 distance, if a charge q is there, this q is enclosed in the closed surface, enclosed in this closed surface, which closed surface is the cube, what we have imagined, right? Then what is the flux gone to this? According to our Gauss law, total flux is equal to q by epsilon naught, or 1 by epsilon naught times the charge enclosed in the surface. Yes or no? So phi total is equal to q by epsilon naught. But the question is, use Gauss law to obtain the expression for the electric flux through the square, through only the square, which is in black you are seeing, through that square how much flux is going. Now see, this is the total flux, right? Throughout the closed surface in all the directions what flux is going, that entire total flux is equal to q by epsilon naught. But there is a q, and through the q, if in all the directions the flux are going and the total flux is this much, in the q how many sides are there? There are 6 sides, isn't it? So from all the sides q by epsilon naught times the flux is passing. Per every one side, any one side if we take, isn't that a square? One face we take, 6 faces are there. Through 6 faces this much is going. Through only one face how much is going? Phi is equal to 1 by 6 times q by epsilon naught. That is 1 by 6 times the phi total. This is the answer to this question, because in the question it is asking calculate the flux passing through the square, means through one face only. So this phi total was through all the 6 faces. So per every one face 6 are going. 1 by 6 times q by epsilon naught is going. I hope you understood the concept. See, I am making another cube. If it looks a little, if it's not, we can also make it. So inside this q is there. Now from the q, what is the number of field lines are coming outside? If that total number of field lines coming outside is called the flux. If that total flux is a phi total we mention, and that is passing through 6 faces, right? By one face, what will be the total flux of passing? 1 by 6 times the total flux. And the total flux according to Gauss law is equal to q by epsilon naught. So phi, what is asked in this question, is equal to 1 by 6 times q by epsilon naught. Hope it's very clear to everybody. Now, there is a second part of the question. The second part says, if the point charge is now moved to a distance d from the center of the square and the side of the square is doubled, explain how the electric flux will be affected. Now understand the question. the distance from the center of the square was d by 2. The distance of this charge q from the center of the sphere, from the center of the square, was d by 2. Now that is increased to d. I am rewriting that again. So from the center of the square at d by 2 distance, the charge was there. Now that is taken to d distance. The q same charge is there, but the distance became d now. The distance is d now. But at the same time, it also mentions in the question that if the point charge is now moved to a distance d from the center of the square and the side of the square is doubled. The side also is doubled. This also is doubled. That means the square also, the side of the square also is doubled, and the distance from the center is become d now. Instead of d by 2, it became d now. What will be the change in the flux? If it was a regular class, I could have asked this. Here a little brain should be applied. You should do. You please think with me. Now see, there is a cube here. Inside this, a q amount of charge is present. Now, how many field lines are coming out of it? We don't know. It's a very huge number of field lines are coming out, which consists of the flux, right? Now, let us say the total phi total is equal to some number. Let us mention that by phi total only. Now, if I don't change this charge and double the size of each side of the cube, then the cube is become bigger. Now, do you think there will be any change in the total flux if it is doubled? Don't you think that the same number of field lines only will be passing through the cube also? So, as long as the charge is not changed, only if the charge is contained in the closed surface only, and however the shape of the closed surface is changing, or it is doubled or tripled or whatever, or instead of a cube if it becomes spherical, or whatever shape you take, the total flux will remain changed only. So answer to this question will be, there will not be any change in electric flux as long as the charge enclosed in the surface is not changing. So some of you have got it already, but who didn't get, for them I am explaining it again, showing it in a 2D. Let us say it is plus q charge is there. All the electric field lines coming out of it are, let us say, 8 in number. In actuality, these are many huge, infinitely large, but let us say I am showing 8 only. Now the radius of this circle is 2 centimeter, let us. And in the next case, I made it to 4 centimeter. So what is the flux going out? Those 8 lines only are passing, right? So flux will remain same. Instead of 2 cm, I made it a 3 cm. So 8 lines only are going out, right? So the total flux is not dependent on the size and also not dependent on the shape. For example, instead of taking it, I will be taking a square. Then also throughout the square, how many lines are passing? It is same only. If I am making a bigger square, it is same only. What I explained you in a 2D, the same thing now imagine in a 3D. And the answer to this question, what is asked, will be very much clear. Now, hope everybody are clear about the concept electric flux and Gauss law by now. So, thank you everybody. Any questions, comments, suggestions, etc. are welcome. You will give in the description, in the comment section of the video. Thank you everybody.